Chris, I might tomorrow. It's gonna be really
Oh, we need a freaking textbook.
I think I got it like the moment I get started. I get it
Did you take your interview yet?
No, I was just talking about.
Rather stupid game.
The moment that.
Yeah, but you absolutely adore this book.
I have mine on Friday.
I swear I'm not already.
You're actually marked as parent contact, so
For the entire day.
I don't know.
Yeah, we should
I'm marked as parent contact, so you guys.
Some stupid.
I'm only supposed to be parent contact.
I'm just saying you need to tell the office here in a bit.
Am I marked as parent contact?
Yours is marked as dismiss at 2:35.
2 when?
2:35. What time do you think it says?
2:15.
All right, 2:15 is probably right. Okay, I need y'all to, well, first off, if you did not turn in your homework, which was 110, the long division, synthetic division, I need that into the basket with your name on it, please. You will also need a calculator today, and number today's handout is 111. Listen, Brian. All right, so I think last class I had mentioned our last big unit. We might be able to sneak in 1 or 2 quizzes besides this, but our last big unit would be sections 2.5, 2.6, and 2.7. 2.6 and 2.7 kind of blend together. They're all kind of the same topic, and you don't need to worry about what that is because we're not there yet anyway. But we are now looking at section 2.5. And this is over the fundamental theorem of algebra. So we need to review what that says, what type of questions to look at, and we need to look at about half of the book assignment together because the book assignment does have a couple questions that I guess y'all didn't do in Algebra 2 that normally y'all do complete before this class. So I need to give a little more assistance there. Okay, but section 2.5 is on the fundamental theorem of algebra. Fundamental theorem of algebra, which is not as hard as it sounds, but it is as important as it sounds. And you probably already know this, but you may not have known it was the fundamental theorem. So when we say like find all zeros, like we're going to do for questions 1, 2, and 3, how do you know how many zeros something has? Right. The degree of the polynomial is the same as the number of zeros, the number of solutions that he has. That's the fundamental theorem of algebra. So that's why all quadratics have 2 solutions. Third degrees will have 3 solutions. A 10th degree would have 10 solutions. Now, the zeros could be real zeros, which show up as x-intercepts, or they could be imaginary zeros. Just like quadratic formulas, sometimes you have I in your answer, and imaginary zeros don't show up as x-intercepts. Real zeros do show up as x-intercepts. Okay, so a big theme in this lesson is we know a lot about quadratics. So, of course, we always want to be able to factor a quadratic because that's going to be the quickest way to approach it. But at the end of the day, if we really have to, we can always apply quadratic formula. So we'll have to do that a couple times today. But we have reviewed this recently, so make sure you know what the quadratic formula is. I'd say one common mistake is not making this be negative. Be careful with the discriminant arithmetic. As much as I tried to bug you about that, I would still say that was one of the more common issues on our last test. You guys even had a calculator, so you could have typed it in your calculator too. If this breaks down, then we should break it down. 60 is like 2 times 2 times 3 times 5. So 2 square root of 15. And then finally, what was the last step you had to do sometimes? You gotta say it louder for me. Right. So reduce your fraction. If everything is divisible by the same number, you need to do that. So divide this by 2, and you get 4 plus 1 square root of 5, and 4 minus the square root, or square root of 15, and 4 minus the square root of 15. Again, I'm talking about that a little bit quickly just because we have practiced a handful of those fairly recently. But that's something to keep in mind. On our longer questions today, even if something's not a quadratic, if we can break it down into a quadratic, then at least we could do this if we had to. Not our first choice, but it's at least possible. Okay, if it's not a quadratic, like question 2, then obviously you can't use quadratic formula. Just so you guys know, there are other formulas. There's like a cubic formula and a quartic formula, but they're very, very complex. In fact, I don't know if I've ever seen them, but that wouldn't be anything you would learn unless maybe you got like a doctorate in mathematics or something. You might have to learn that. But the rest of these just kind of depend on what you have. Sometimes you have a calculator and that helps. Sometimes a factor and that helps. Sometimes we give you a hint. For these next two, we're going to look at them just no calculator and no hint. So where the zeros are, if we don't give you a hint and we don't give you a calculator, then it needs to factor. So that's the difference of two squares. You've got x squared being squared on the left and 4 being squared on the right. If you have something that still factors, you should do that again. You always want to factor completely. And then where this equals 0 would be one of our zeros. Now this is a degree 4, so I know that there should be 4 zeros here. So personally, I like to have 4 blanks. This equals 0 at -2. This one equals 0 at +2. And then even though this one doesn't factor more, we could still solve this. Now I guess you could use quadratic formula, but that's going to take a lot more work than you need to. Really all you need to do is subtract the 4 over and take the square root of both sides. What's the square root of -4? 2i. Now, if you make enough blanks, if you say this is a 4th degree, so I should have 4 answers, sometimes like this, I just kind of glossed over my mistake. You're going to say, wait, there's supposed to be one other one. So what did I fail to do here? Okay, why? Right, when you take the square root of both sides, you need to do plus or minus. So in this section, if you forget that, it's a little bit easier to catch if you're paying attention to how many answers you should have. Okay, one more like this. So again, we're not giving you a clue. You'll see on the next page what I mean by that. We're not giving you a calculator. It's not a quadratic, so you can't use quadratic formula. So the only way to do this would be with factoring. Now by the way, just because this is x to the 4th, that product sum method that I showed you earlier this year still works out fine. So you don't have to do guess and check. 6 plus 8. You don't have to do guess and check, but you should always try guess and check first, because that's all that practice is how you eventually get good at doing that. Okay, so where does x squared minus 6 equal 0? Good. And then square root, or x squared plus 8 equals 0. When x squared is -8, take the square root of both sides. Don't forget plus or minus. The negative needs to come out as an I. And how did the square root of 8 break down? So do the factor tree and all that kind of stuff if you need to. But 4th degree, so there should be 4 zeros. Doesn't mean all 4 of them will be real numbers like the first 2. Some of them could be imaginary numbers like these 2. But that should have 4 solutions. 4 zeros. Okay, okay with us? Okay, we're actually going to come back to 4 because question 4 and question 5 are the same type of question, but 4 is like the longer, more difficult version. So it kind of makes sense to start off with number 5. So in question 5, now I'm giving you something that does not factor. It's got too many terms there and grouping just doesn't work. Factor by grouping doesn't work. But what we are giving you is one of the factors. So we're giving you part of the answer. And I'm just going to write it down here anyway. I know it says find remaining ones, but if this is a 3rd degree, we should have 3 zeros. And 3 factors. It's basically the same amount of work to do both of them. Okay, so without a calculator, without being able to factor it, without it being a quadratic and being able to use quadratic formula, you have to have some way to move forward. Good, division. This is why we did long division and synthetic division last time. You can either do long division and divide out x plus 4 that way, if you prefer it. My personal preference is I'm always going to do synthetic anytime I can, just because I think it's a little bit quicker. But before I do any of this work, there's part of this that you should anticipate. What has to be true when I'm done with this? Why does the remainder have to be 0? Right, and to be a factor, what it means is it divides into it evenly, so no remainder. So you've got that little bit of a check that you didn't have last class. That wasn't necessarily true when you're just dividing. But we added down, multiplied, add down, multiplied, add down, multiplied, and 0 hour today. I did that arithmetic a little bit too quickly, but again, because I know that's a factor, I know it divides into it evenly, so I was able to see that I made a mistake before I got too far into it. Okay, so she told us to do division. What do these 3 numbers now represent?
Coefficients
Of what?
of
I've got 6 whats?
6x cubed squared.
Right, if it was cubed and we divided it out, now this is squared, x's, and constant. You can add the remainder over the divisor, but since it's 0 divided by something, it just goes to 0 anyway. So how does that help us? Now it's what? Right. More specifically, even if it doesn't factor, it's a quadratic, so even worst case scenario, if we had to do quadratic formula, at least we have a path to finish the question now. This one does factor though, and so if you're asked for the other factors, there they are. If it had said find the other zeros, where each of those factors equals 0. So that's the connection with the long division, synthetic division that we did last time. Bless you. Doesn't matter if it's not a quadratic. If we have enough information to lower the degree to a quadratic, we just have a lot more experience solving quadratics, so we should be home free from there. So backtrack to question 4, which is kind of the same thought process, but a harder version. This is a 4th degree, so there should be 4 zeros. This is a non-factorable one, and I'm not telling you to get out your calculator yet. So in that case, we have to give you a hint, and the first hint is that we'll tell you one of the zeros. Now, there's something different about this one though, where if you're told this 0, there's another one that you should know.
2 negative.
2 what?
Oh, yeah.
2 minus I. And the reason is, and you are expected to know this, that imaginary zeros always come in conjugate pairs. So if 2 plus I is a 0, 2 minus I has to be a 0. Sometimes you have to know that to move forward. So make sure you write that in your notes here. Now sometimes you just accidentally discover it. Like look at question 2. We had 0 plus 2i and 0 minus 2i. Imaginary zeros came in conjugate pairs. Question number 3, we had 0 plus 2i square root of 2 and 0 minus 2i square root of 2. Imaginary zeros always come in conjugate pairs. Okay, so if I relate this now back to question 5, in question 5 we took one of the zeros, divided it out, and lowered it from a 3rd degree to a 2nd degree. Well, if you try to do synthetic division with this, I'm going to make a little row for factors. To go from a 0 to a factor, you just have to do x minus the 0 and distribute the minus. If I try to synthetically divide by 2 plus I, that is going to be a nightmare. You're going to have i's all over the place and it's going to be too hard to keep up with. In theory, I guess you could then synthetically divide that mess by this one, and then it does clean up quite a bit. Likewise, if you just long divide by this, it's going to be a mess with i's all over the place. Then if you long divide by this, it will come out nicely. But what you really should do is, instead of dividing by this and then dividing by this, let's just divide by both of them at the same time by multiplying them together first. So we're going to distribute these two things and make it and see what it looks like. So to distribute these three terms to these three terms, x needs to be multiplied to all three of those, and then negative 2 needs to be multiplied to all three of those. Bless you. And finally, negative I needs to be multiplied to all three of those. Three things times three things should give you 9 things. Now that looks awful as well, but once you slow down, you'll notice a lot of this stuff just cancels out. Plus xi minus xi plus 2i minus 2i. We have an x squared minus 2x becomes minus 4x. And then there's some way that we combine plus 4 and a minus I squared. So I don't think I squared has come up with us this year, but I did ask you to know what I was equal to. What is I equal to? Okay, and so if you really know that, you could square this side to get I squared and square this side to get what? Not 1, negative 1. So this is really like minus a negative 1, so this is really just like a plus 1. Combine that with your plus 4, you get plus 5. So these two really strange looking terms are actually the same thing as this trinomial. These two things are equal. This one just looks a lot nicer. So the purpose of multiplying these together is so that I didn't have to divide one of them, get something insanely messy, and then divide out another one and just make it really hard. I multiplied them together so that now I can divide them out. Can't do synthetic division here. We have to do long division. Whoops. Okay, and unlike last class, just like the synthetic division, if these two were factors and they just got multiplied together, we should at least know at the end of this long division it should divide into it evenly. We should end up with the remainder of 0. So go through the long division process. Make sure that you switch the signs and add. Go again. Switch the signs. Oh, wait, this one was positive, so when I switch the sign, it's now negative. And add. Understand why it's supposed to have a remainder of 0. And then I guess probably most importantly, doesn't matter if you can do this stuff if you don't know why you're doing this stuff. Why did I divide this out of the original question?
You can, so you can use it to.
Okay, so what part of this am I interested in? The what? What's this called?
Answer.
The quotient. The quotient.
Yeah.
I said it last class. So if you needed the other factors, notice it's set up difference of 2 squares. If you needed the other zeros, you could solve them. But when you started that question, no way did you see x squared minus 4 in the beginning. You really had to divide out the stuff that was given to you. And on this question type, because of these zeros, and they weren't just nice whole numbers like question 5, change them to factors, multiply the factors together, then it looks a lot nicer, and then you can knock out both of them at once. So an x to the 4th divided by an x squared is going to leave behind some x squareds. So that's how you were supposed to discover those last 2 parts. Okay, so a lot going on there. Any follow-up questions to that? Okay, then let's skip down. 7 is not much different, it's just really knowing the directions. But 6 is kind of asking you to work it backwards. So instead of saying, hey, here's a function, go and tell us find what the zeros are, this is saying, hey, here's the zeros, and then you tell us what the function is going to be. And I don't know, probably not that you care, but this is a lot of times what we have to do as math teachers. Like if I wanted a question like this on the test, I don't just pick a random function and then hope that it works, and I hope that it's a good difficulty level, and I hope that the answers come out to be something like I would expect. I would start off like this. If I have zeros of 1 and 6i, well, first off, how is this supposed to be a 3rd degree if there's only 2 zeros? Okay, so it's implied. I told you that you would have to know this sometimes. Imaginary zeros always come in conjugate pairs. And to change zeros into factors, you just have to do x minus the 0, because this equals 0 when x equals 1. Do the same thing here. X minus the 0, distribute the minus. X minus the 0, distribute the minus. Now, if the question said factored form, that would be my answer. What's kind of a pain about this question is it wants us to multiply all this together so that we end up with real number coefficients. So we'll come back and multiply the x minus 1 later. Let's multiply these 2 together. These are the 2 messy ones, but just like we did in the last question, when we multiply these together and combine like terms, it gets to be a non-messy quadratic. So x needs to be multiplied to all 3 of these. That would be 3 terms. Then multiply -6 by all 3 of these. And then multiply I by all 3 of these. Combine your like terms. Xi minus xi, 6i minus 6i. We've only got the 1x squared. We've got minus 12x's. And then what did these two combine to be? 35, 36, 37. 37. Because this is like minus a negative 1, which is like plus 1. That's why it's 37. So that's what I mean. It looks really bad for a second, but since so much of it cancels out and all the I stuff goes away, it's really not that bad. Alright, finally we can distribute it in this one and then be finished. So x times all three of these, and negative 1 times all three. Combine your like terms. And now we have an answer that is a third degree polynomial. The biggest degree is 3. The biggest exponent is 3. And he would have zeros at 1, 6 minus I, and 6 plus I. And I know that because I created it from the factors that give you zeros of 1, 6 minus I, and 6 plus I. Now, if I was to graph this, what would you expect to see as far as x-intercepts go? Okay, well, where's this going to be on the x-axis? Okay, which one?
1.
Okay, and why would this be an x-intercept and not those?
Because it's not imaginary.
Right, real zeros show up as x-intercepts. Imaginary zeros do not. So I will graph it quickly for us so that you can see what I'm saying. That was the original equation. There's only one real zero, so there's only one x-intercept. Okay, and then the last question type isn't really anything different than we haven't talked about on here, except that the directions for this do throw people off sometimes. So product, you need to remember, means multiplication. We want factors. So this factor times this factor times this factor times this factor. So multiplying them together instead of just separating them with a comma. But for me to tell you what the factors are, I probably want to figure out what the zeros are first. Because if I know what the 4 zeros are, then it's easy to change those into factors. So just like we did on the front page, we don't have a hint here. We're assuming we don't have a calculator on this one, but he factors like this. This equals 0 at square root of 6 and negative square root of 6. And this equals 0 at I and negative I. So if you want the product of 4 linear factors, just do x minus each of these, and then you've got your answer. Now what does it mean by this? What does it mean by linear factors? Well, weren't these factors back here? Why couldn't I just circle this as my answer? Because that would have been easier.
Otherwise, it's just like factors.
They're what factors?
Factors for, I don't know how to say it, just spread out.
Yeah, these factors are quadratic. The exponents are 2. Linear means your exponents are 1. X to the first on all of them. So again, not actually easier than most of the questions on here, but you do need to make sure you know those directions. I say that every year, and then when you see 1 or 2 of these on the tests every year, a lot of students miss all the points because they don't know what that means, but it's not really any different. Just make sure that you write that out in words as needed. Okay, anything that jumps out at y'all from the notes? You remember doing most of this in Algebra 2?
No.
No.
his stuff.
Like some stuff similar to it, but not.
Probably not anything quite as.
Yeah. We spent like 2 weeks on I.
Hmm?
We spent like 2 weeks on I. Like the last 2 weeks of school last year.
Okay.
I.
Yeah, the first time you learn something, you need to spend more time on it.
Yeah. We never did this one.
Good. Well, I'm glad we're doing it then. Okay. So next up, you need a piece of paper. If you go ahead and copy the assignment down and do 9 and 13. 9 and 13 are about 5-second questions, so those should be quick. And then something comes up in number 15 that my other classes said they didn't remember in Algebra 2, and you need that for a few questions, so we need to look at that one together.
Nine's easy. It's just asking you how many zeros there are.
I know, I said it was 5 seconds.
Oh.
I said the first two are very quick. I did update on our screen here when our next quiz is going to be. So just to verbalize it, it is not, this stuff is not quizzed next class. Bless you. This is a B week, so I will not see you guys on Friday. But our quiz is also not next Monday. It'll be this time next week, so we get 2 days in this section. But if a lot of that was unfamiliar to you, then it might take a little bit more effort. But notice there's not a lot of questions here. Hmm?
It's in a week or 2 weeks.
It's a B week. Okay, so you should be finished with number 9 and number 13 already, because they just want to know how many zeros there would be. So number 9, how many zeros are there? 3, because it's a third degree. And what about number 13?
2.
There are 2. Be careful not to think that there's 1 because of this. If this is squared, you could take this and multiply it by itself twice, FOIL it out, and then it's a little bit easier to see that there's 2 zeros, 2 solutions. Okay, I assume you guys are okay with that. Okay, number 15 is the thing that comes up that I don't know if anyone has recognized, something called the rational zero test, which I'm a little bit surprised about because it's not hard to learn at all, and it used to be on the ACT. I don't know if it still is or not, but you certainly need to copy this down. Normally I would have this on the other worksheet since I kind of consider that some notes and practice, but I didn't realize that y'all were not doing this in Algebra 2 anymore. The rational zero test, which is oftentimes just called the P over Q test, is a way to find the possible, important word, rational zeros. And so what the rational zero test says is do plus or minus all the factors of P and divide them by plus or minus all the factors of Q, where P is the constant and Q is the leading coefficient. So over here, In this problem, P is -2 and Q is 1. Now it doesn't really matter that this is -2 because we do plus or minus anyway. So remember, factor just means something that goes into it evenly. So the factors of 2 would be 1 and 2, but we're going to do plus or minus each of those, divided by plus or minus all the factors of Q, the leading coefficient, which is 1. The only number that goes evenly into 1 is 1. So that's what they're looking for an answer here. These are not hard questions to answer, but if you don't know what it represents, it's not really useful. So if I wrote this out the long way, which most of the time we don't because some of these lists can be pretty big, it's saying any of these over any of these are possible rational zeros. So we could do like 1 over 1, -1 over 1, 2 over 1, -2 over 1, and anything else would be a duplicate. Okay, so am I saying that all 4 of these are zeros? How should you know that that doesn't make sense?
Because there's not 4.
Right. It's a third degree. There's no way that there's 4 of them. This test doesn't tell you what the zeros are. It tells you what the possible rational zeros are. It's not going to list out any imaginary zeros. It's not going to list out any irrational zeros. But of the rational zeros, it has to be in this list. So even though it doesn't narrow down for us, this is a 0 and this is a 0, it does tell us indirectly some stuff. Like 3 is not in this list, so there's no chance that 3 is a 0. 5 is not in this list, so there's no chance that 5 is a 0 or an x-intercept. So what they want you to do in this question is then look at the graph. So looking at the graph, what are the zeros of this function?
-2, -1.
And do you see how all of those were in the possible list? -2 was possible and it was 1. -1 was possible and it's 1. 1 was possible and it's 1. 2 was possible, it just didn't end up being a 0 this time. So that's what it's trying to say. It's giving us a list of things that are likely. Or if you looked at that and you thought, hey, I think that goes through 1/2, well, 1/2 is not in this list, so there's no way it's 1/2. So it helps you kind of indirectly like that. So 16 is the same type of question. So if you would go ahead and try to write out the rational zero test, write the P over Q list like I have highlighted there. You don't have to write it like this. Just write it like this. This is how it showed up on the ACT. This is how most people write it. But try to write that and then compare that to the graph and see if that connection makes. Yeah, 16 is the next one.
Oh.
Okay, so the answer to number 16 should not take too long. If you know which one of these is P and which one is Q, I just always remember that it's not alphabetical, like P should come before Q, but if it's in descending order like this, Q comes first and then P, so that's just how I remember it. So plus or minus all the factors of P, so all the stuff that goes into 16 evenly, over plus or minus all the factors of Q. Those are the possible rational zeros. Again, not all of these are zeros, and it should make sense that they're not all zeros because there's only 3 zeros and there's like 10 different things here. But the fact that 3 is not on the list tells me that 3 could not be an x-intercept. 9 is not on the list, so 9 could not be a solution to this. It still helps me identify some stuff that's not. So to connect that to the graph here, it looks like it goes through 2, 4, and -2. And notice 2, 4, and -2 were all in the possible list.
Oh, it's so hard.
Yeah, you're welcome.
Blushing.
So does that make sense what the test is telling you? Because again, you don't have to, like, it doesn't take much. This is what they're looking for as an answer, this box here. But if you don't know what this is telling you, then it's pretty hard to apply.
Would it get all those numbers right?
It's all of those.
Okay.
All of those are possible. And we'll look at one next week on Monday where we talk about, without a calculator, how to graph this. If it doesn't factor and you're not given a hint, sometimes you can use this to help you. And that's what I used to make my Algebra 2 students do. But it kind of gives you a little bit more perspective on why that's important. Okay, we need to also look at number 31. And then I think I can let you work at your own pace at that point. I think you will have seen a little bit of everything. Obviously, I'll still help you if you need help, but I think the next couple are like this one. Okay, so 31 gives us something where they don't give us a hint, and they don't give us a graph, and it doesn't factor, but they expect us to find all the real solutions. So first off, it could have 4 solutions. I don't know if they're all real or not, but 4 is what I'm aiming for. I like to make the 4 blanks so that way I kind of remember that there's something else to be done. So in a case like this, and this would be the same for us on a test, if it doesn't factor and we don't tell you one of the zeros, we don't tell you one of the factors, and we don't provide the graph for you, what we would do on this question is we would have you, or let you have a calculator, and so what you would want to do is graph it. So I will do that for us. But what part of the graph are we going to be interested in?
X-intercepts.
All right, we are interested in x-intercepts. And ideally, we get 4 easy to find x-intercepts because it's a 4th degree. And at first glance, it looks like this is going to be a real quick question. So, this far right one, what does that look like?
1.
Okay, so to be sure, if you hit trace 1, enter, it will jump to that point, and down here it looks like 1, 0 is a 0. So there's one of our 4. That's why I'm saying you hope that you just see all 4 because you're going to be done quickly. What does this one look like?
1/2.
I would probably guess 1/2 too, but if you do trace,
Maybe 7/16.
yeah, it's not going to be 7/16, but it's also not 1/2. If you do trace 1/2 enter, y is not 0. Y is just close to 0. So you can't assume that this is -1/2. So unfortunately, I don't know that one yet. What about this one? What does that look like? Okay, trace Negative 3, enter, jumps to that point. Negative 3 is exactly 0. Okay, and any guesses for this one?
Negative 5/16. Or, yeah, never mind. Yeah.
Well, that
It would be
5/16 is less than 1, so.
Yeah. But like, after that one. After
Negative
that
4
one.
and 1/3. Negative 4.33.
How about negative 4.5?
It looks like
No.
it won't be.
Yeah,
You what?
yeah, that's why we said negative 4.
Okay, what is that as a fraction?
Negative 4.3. Yeah.
Negative 13/3. Okay, also not it.
Oh,
Okay, so it seems like
2/5.
It's in between those two.
2/5 is between 0 and 1.
Huh?
Well, I mean like negative 4 2/5.
Okay, that's not what you said though.
Negative 400
Yeah.
That's like.
Okay, Christian,
Eight.
we're done with that.
Oh.
All right, so we got 2 answers, but we need 4. Could be that these 2 are imaginary and I don't have to find them because it said find real solutions?
No, they're real.
How do you know they're real?
Because we saw them we got.
Right, they're on the x-axis. All real solutions will be x-intercepts. So, how am I supposed to find these other 2 that must be somewhere decimal?
Oh,
You
you,
reduce the zeros to
you
divide.
multiply them. Well, you multiply the factors, like x
Okay.
minus 1 or.
You could go that route. Or, if I divided this by 1, I just prefer synthetic division. I just think it's a little bit quicker. Because that's a 0, it guarantees that you get a remainder of 0, right?
Yes.
So, synthetic division, add down and multiply, add down and multiply, add down and multiply. Just keep on doing it until you confirm that it goes into it evenly. So I just kind of algebraically confirmed that 1 was correct. I mean, I guess I could have typed the equation in my calculator wrong or something, so that's a good check. So if I started off with the 4th degree and I just divided out an x, this now represents a 3rd degree. Well, I don't know much more about 3rd degrees than I know about 4th degrees. But I know 1 more that should go into it evenly. So don't divide negative 3 into the original. Divide negative 3 into the already reduced one. And it's also a 0, so we can also anticipate a remainder of 0. So do the synthetic division. See that you get a remainder of 0. And then you're 100% sure negative 3 is 1. And now I'm out of zeros. So how am I supposed to move forward?
Check the factors reflect the equation.
Okay, so what do these 3 numbers mean?
X squared is 4x plus 2.
Okay, so the number of x squareds, the number of x's, and the constant. And again, like we started off class today, I said, even on the bigger polynomials, the bigger degree polynomials, if we can do some work to get it down to a quadratic, obviously I hope that it factors, but even if it doesn't factor like this one, we always have a plan to be able to finish. We always have quadratic formula. And so it looks like we get negative 4 plus or minus the square root of 24, which is 2 square root of 6. And then our fractions reduced here. Negative 4, 2 square roots of 6, and 2 are all evenly divisible by 2. So divide them all by 2. And it looks like one answer, one of the zeros is negative 2 plus the square root of 6. And the other one is negative 2 minus the square root of 6. That's why we weren't going to guess those decimals. They were close to things we expected, but they weren't exact. And while this is still in my calculator, I still have the graph there. I can check these in about 2 seconds, the same way I was basically checking these from guess and check. if I do trace -2 plus the square root of 6, enter, it's going to jump to that x value, and that x value is supposed to give me a y value of 0.
That was gonna be my next guess.
-2 minus the square root of 6 also checks out.
I would've been right. I should be
So,
wrong.
again, we're never going to guess this decimal, but with synthetic division and understanding how all these kind of skills tie into each other, we can figure out that exact value even though it's something kind of unusual. So, again, longer questions like this, I don't think most of the rest of them are like this, but I know those aren't your favorite. But you do kind of have to appreciate how all this stuff kind of comes together. Where synthetic division can help, how knowing imaginary zeros and versus real zeros and how they look on a graph, and how if you can get something down to a quadratic, we've got quadratic equation to solve, and sometimes in quadratic formula you need to simplify your radicals. It really just ties together a ton of different skills into doing something that normally you would just hope your calculator would do for you. So. Okay, so that was 31. 33 is the same type, except I think it's a little bit easier. I think you get more information out of that graph, if I remember right. 37 is some of the same stuff, but they also want you to make the P over Q list. 41 and 43 are the questions that you work backwards, where you get to zeros and you need to multiply them together to come up with the function like we did in your notes. And then 59 and 60 are the same type of questions, and we did some of those in your notes too. So I'd like you to move on and try to finish those in class, please. And if you don't finish those in class, that's what I need you to do for homework between now and Monday. But again, our quiz on this is not next Monday. Part of what we will do on Monday is look at these last couple questions together, but I want you to try them on your own first. Is it relevant?
Well, you've got something unplugged down there. I didn't know if it was important, just so you were aware.
No, I don't know. Everything's working okay, so I'm not worried about it right now, but thank you. Okay, so obviously you guys are welcome to ask questions as you see them today, but I do plan on us looking at it again on Monday. Hard copy of the final review there. Some of these things won't be the final because you won't get to them. But some of the stuff that is we should start kind of do a few questions each day so that it doesn't seem like too much at the end.